we are actually putting our own biases, we're putting the developer biases in the systems, and it's influencing society in the world. Whereas people, when they're using it, they just think that in some cases, robots don't do a good job, doesn't matter what the gender is. In some cases, they do. Lastly, I want to talk really quickly about race and why we shouldn't basically racialize our robots. So there was basically a researcher that did a shooter bias test, which of course it sounds ridiculous, but that's what they did, where they basically wanted to see what is humans' response if a robot was racialized as black or white, and seeing who would you shoot first. And what they found was that individuals were more likely to shoot the racialized black robot faster. And so based on this about why we shouldn't, we did another similar test where we showed, we basically prompted race on the robot, and then we did not prompt race on the robot to see, is it that us as developers are influencing this? And what we found just in general is that when we didn't racialize it as roboticists, people viewed the robot equivalently. And when you racialized it, i.e. identified, primed, prompted, people did treat them differently. And therefore, and this was with respect to race, I also believe we should not racialize our robots, just like I believe we shouldn't genders. So I think there's hope to do this right. The focus is on people, thinking about people first, and not try to put our developer biases on these systems, and also think about the role of diversity and taking away this aspect of robots being diverse. People should be diverse, but robots should be robots. And with that, I'm done. Thank you.
Awesome. Thanks a lot, Dr. Howard. This was fascinating. I think the findings on the biases were really surprising and something to take care of. So we will have the Q&A at the end, but please feel free to leave your questions in the Zoom chat for now. We'll move to the second speaker. Our second speaker is Dr. Milind Tambe. Milind is a professor at Harvard University and Director of AI for Social Good at Google Research in India. Over to you, Milind. Please go ahead.
Okay. All right. So thank you for inviting me. And so for the past 15 years, my research group and I have focused on applying AI and multi-agent systems for social impact, focusing on topics of public health, conservation, and public safety and security. The key idea is how to optimize our limited intervention resources. So with respect to public health, we have a large population to serve, but limited number of social workers or public health resources. Concrete example is work we've done with youth experiencing homelessness in Los Angeles. Harnessing the social networks of these youth, we are able to show that our influence maximization algorithms are far more effective in reducing HIV risk behaviors compared to traditional approaches. The technical areas we focused on here are social network and bandit algorithms. With respect to conservation, we have large conservation areas to protect limited number of ranger resources. Concrete example is work we've done in Uganda and Cambodia. Harnessing past poaching data, we are able to predict where poachers set traps or snares, and for the past several years have been able to remove large numbers, hundreds or thousands of these snares. The technical area we focused on there is green security games, which combines machine learning and game theory. With respect to public safety and security, our focus has been counterterrorism. And here we've provided a new model called Stackelberg Security Games and provided new algorithms that have been used by the US Coast Guard, the Federal Air Marshals, and so on. Today, I'll focus on public health and conservation, which is also the focus of our work at Google Research India, where we've been working with several nonprofits. Given the limited time, I'll highlight one of the projects from there today. So as you look across all of these projects in our work, you'll see, of course, the emphasis on multi-agent systems work, social networks, game theory, etc. But also this data to deployment pipeline. We start with immersing ourselves in the domain, trying to understand the kinds of data that are available. Following that, a machine learning and multi-agent intervention modules basically tell us what to prediction and the prescription on what cases to intervene on. But it's very important for us to actually field test and deploy our work. This is because we want to understand what are the weaknesses of our models and algorithms and improve upon them. But also social impact is a key objective. It's a first-class citizen of the work. If we are saying we are doing AI for social impact and we don't achieve social impact, then it's not quite AI for social impact. And finally, interdisciplinary partnerships. All of the work we do is in service of the work that are being done by nonprofits, whether they are homeless shelters in Los Angeles or nonprofits serving young and new and expecting moms in India. Our ultimate goal is to empower nonprofits to be able to use these AI tools in the inspiring work that they do and avoid being gatekeepers to using AI technology for social impact. So I'm going to go through 3 projects today, just to give you a flavor of the kind of work that's been done. The first one is preventing HIV amongst youth experiencing homelessness in Los Angeles. There's 6,000 homeless youth who sleep on the streets of LA. The rates of HIV in this population are 10 times the rates of the normal housed population. So you can't go and talk to each of these youth about HIV risk behaviors. So homeless shelters do invite peer leaders. They select peer leaders, educate them about HIV, hope the peer leaders will talk to their friends will talk to their friends, information will spread in the social network. This is real face-to-face social network. Okay? This is not Facebook. Now, this is the classic problem of influence maximization that we know in computer science. Given a social network graph G, we're trying to choose K peer leader nodes to maximize the expected number of influence nodes. But if we apply it directly to our domain, we see 3 major challenges. We need robust influence maximization in order to mitigate the uncertainty in information propagation in the social networks. We need multi-step dynamic policies because we can't invite all of the peer leaders all at once. So you invite a group, some show up, some don't, then you bring up the next group and so on. And the social network itself is not known ahead of time. So we have a limited query budget to sample the network, and we must work with this sampled network. So in our papers, we show how to address these challenges, and then having addressed this, we developed a system called Sampling Healer. I emphasize the word sampling because the system does not know the full social network. And it handles network sampling, robust policies, and multi-step policies, as I mentioned. And it will say, bring in these peer leaders in the first batch, observe who showed up, who didn't, then bring in the next set of peer leaders, and so forth. We ran then a pilot test with 230 homeless youth. There are 4 different arms to this test. So first one, Sampling Healer, the sample network, bring in 60 youth. Healer, which is exactly Sampling Healer, but knows the exact full network, 60 youth. Healer Plus is a version of Healer. And degree centrality is the more traditional approach of bringing in the most popular youth, the nodes with the highest degree in the network. We recruited 12 peer leaders in each case. These were recommended by the particular algorithms. And then our social network colleagues educated these youth about HIV prevention. And then after a month, the question is, how many of the non-peer leaders who we did not bring in got informed about HIV? And here's what we find. With degree centrality, only 25% of the non-peer leaders get informed. But with Healer and Healer Plus, 70% of the youth got informed about HIV. So clearly, these influence maximization algorithms are doing a great job. Sampling Healer, the one we just sampled the network, actually did just as well as Healer and Healer Plus. In fact, it's seeming to do a little bit better, and that's just some experimental condition there. But essentially, Sampling Healer seems to be doing really well compared to this degree centrality. So now it was time to do a full-scale test, which we've recently completed. So this is with the 750 youth. This is done jointly with Professor Eric Rice in social work. And the focus here is not so much on who got informed, but who actually changed behavior. And as far as we know, this is the first large-scale application of influence maximization for public health, done in collaboration with the 3 homeless shelters that are shown here. The 3 arms to this study: Sampling Healer, degree centrality, and no intervention. In each arm, we recruited about 250 youth. We did the peer leader selection and information about HIV. And then we looked at what happened at the end of 1 month, and then what happened at the end of 3 months. So at the end of 1 month, what we see is that with Sampling Healer, more than 30% of the youth, there was a more than 30% reduction in condomless anal sex, which is the HIV risk, one of the HIV risk behaviors we're monitoring. With degree centrality and control, there is no change. Clearly, sampling healers seem to have done a great job here. At the end of 3 months, degree centrality begins to catch up, but still sampling healer is better. The point being that having this information out there faster and behavior change happen faster is important because this is an HIV risk behavior. And secondly, this is a community where people come and go, and having this information out there faster is important. We also looked at other behaviors, condomless vaginal sex, and again, sampling healers seem to have done better than the competitors. So this is going from data to actual field study and deployment. A second program I wanted to talk about is Arman. This is work that's going on with Google Research India in maternal and child care. The situation there is difficult. Woman dies in childbirth every 15 minutes. 4 out of 10 children are too thin or short. We are very fortunate to be working with a nonprofit called Arman, which has 18 million women enrolled, 160,000 health workers. One of their projects is called M-Mitra, which a mobile friend, basically a weekly call, 2 calls to an expecting or new mom. Friendly 3-minute message about health. So for example, it's in the local language. It's just say something like, you are in the 6th week of pregnancy. This is the health supplement you should take. Or your child is 3 months old, register them in this government program. And what they've shown in randomized control trials is that this, if a mom listens to this message through the course of the 150 phone calls that are given, there's significant benefits to the mother and the baby. And 2.2 million women have been enrolled in this program. So all of this is great, except one problem they face is that significant fraction of the women enroll, they start listening, and after a while, they drop off, they stop listening. So Arman waits for these women to drop out. They don't listen to a few weeks. The women are not listening to these automated calls for a few weeks. At that point, Arman goes back to them and says, hey, you're not listening. You should try and listen, live call them, go to their home to try and get them back in the program. But by then, of course, they have not listened to these messages for a few weeks, and it's difficult to get them back in the program. Could we predict in advance which beneficiaries, which moms are likely to drop out so that we can focus our intervention and avoid them dropping out in the first place? So here's how this is supposed to work. Here's mom number 1, didn't listen to the phone call week 1, listened to the phone calls week 2, 3, 4, 5. Mom number 2 listened to the call in week 1 and 2, but not in week 3, yes in week 4, not in week 5. Mom number 3 and 4, etc. So you can imagine hundreds and thousands of these moms. And now it turns out that mom number 2 and 4 and others drop out of the program. So a few weeks, they don't listen to the call at all, and Arman can then try to intervene on them to get them back in the program. Instead, if we could say to them ahead of time that mom numbers 2 and 4 are at high risk of drop off, so that Arman can intervene on them before they drop off, that would be substantially beneficial to the moms and allow us to retain them for longer. So that's what we did. We built a prediction system. It worked well with past data. And then it was time to do a live test. So a pilot test with 18,000 beneficiaries, November and December of 2019. We made predictions January through April of 2020. We find that where we had predicted high risk did indeed. We see a recall precision and F1 scores above 0.8 with respect to our pilot test. So given this accuracy, the system is now out there with Arman making predictions to help among the 300,000 beneficiaries as to who's has at high risk of drop off, and phone calls are going out to them to try to prevent them from dropping or try to avoid their dropping off from this program. So the third topic I wanted to quickly discuss is protecting conservation areas. This is national parks around the globe face a challenge that poachers set traps or snares, thousands of them, to maim and kill animals. And for the rangers, it's a difficult task. Over thousands of square kilometers, keep searching for these snares. Again, can we predict in advance, looking at ranger patrol frequency, animal density, area, slope, and all, what is the probability per 1 kilometer grid square of finding a snare? If we can pinpoint hotspots, then rangers can go there and remove these snares before they maim or kill animals. So we did this first pilot test in Uganda with the Queen Elizabeth National Park. We pointed out these 2 9 square kilometer areas. These are shown by these green dots, which you can see are new patrol areas. They're infrequently patrolled. They don't overlap with the red dots where snares have been found in the past. And we asked rangers, you're going to find snares there. And this just happened 1 month before a conference deadline, meaning if snares are found, we will write a paper. No snares, no paper. And the rangers went out every month, every day they would go out and send us an email as to what happened that day. Initially, there were no reports. Then they said, we found a poached elephant with its tusk cut off. So we were too late for this elephant, but at least the machine learning system was making the right predictions in where the hotspots were. Then they said they found a whole elephant snare roll with its tusk, in the same area. So that means that poachers were active in the area. They were killing elephants, but before they could kill the next set of elephants, the snare roll was removed, hopefully saving lives of elephants. And then a lot of antelope snares were removed. Following the success of this pilot test, we deployed the system in 3 national parks, 2 in Uganda, 1 in Cambodia, made predictions over 24 areas in each case. Some we predicted were high-risk areas, some low-risk areas, so more snares would be found in the high-risk areas. That's our prediction. Rangers went out for 6 months, and indeed, where we predicted high risk, more snares are found. Where we predicted low risk, less snares are found. Numbers of snare captures in Cambodia have jumped more than 5-fold. So this is very exciting, and indeed now we've made this pause system available to rangers worldwide, can be downloaded by rangers around the globe. We're excited to see it going out. Right now, significant testing is going on of the software so that we can start seeing actual usage around the globe. So I'll end here. I'm running out of time by highlighting some key lessons we've learned in applying AI for social impact. First, achieving AI, social impact and AI innovation goes hand in hand. These are not in opposition to each other. Second, we have to have a data to deployment attitude. We can't just focus on improving algorithms. Third, it's important to step out of the lab and into the field, to embrace interdisciplinary work, whether with social work researchers, with conservation scientists. Finally, in our experience, lack of data is the norm. We're supposed to be swimming in big data, but many of these domains, really, we have very limited data, and this must be part of our project strategy. And finally, our goal ultimately here is to empower nonprofits to use AI tools and to avoid being gatekeepers to using AI technology for social impact. So I see that I've reached my 15 minutes, so I'm going to stop here. Thank you.
Thank you. Thanks for the fascinating talk. Again, if you have any questions, please leave them on the Zoom chat and we'll take them at the end of the session. So we'll move to the next speaker. Our next speaker is Dr. Maria de Arteaga. Maria is an assistant professor at the University of Texas at Austin, and she's going to talk about a case for humans in the loop. Please go ahead, Maria.
Hi, everyone. I am very excited to be here, especially following those 2 amazing talks. Today, I'll be talking to you about a case for humans in the loop, and this will have a lot of common threads to many of the things that we've heard about today. And the work that I'll be presenting to you is joint work with Ricardo Fogliato and Alex Schrodoshova, both of whom are at CMU. So in his book, Geek Heresy, Rescuing Social Change from the Cult of Technology, Kentaro Toyama talks about the law of amplification. That is, technology's primary effect is to amplify human forces. And this is a notion that I keep coming back at different stages of my work. And at least in my eyes, it kind of takes on different meanings and implications when thinking about different technologies. And in particular, when thinking about one domain where this notion of technology as amplifying human forces is particularly relevant is that of decision support systems. And in recent years, we have seen an increase in the use of machine learning to support experts in high-stakes decisions. And this goes from settings where we're assisting physicians in their diagnosis and prognosis of patients, assisting call workers in identifying which calls may pertain a child that is at risk, the criminal justice system, and so on. There's many examples. And here there's 2 key elements. There's first, when we're thinking about AI for social good, as Milling highlighted, there's a key element that is we care about whether this social good is actually being realized. And in general, when we're thinking about any AI technology, there's the question of AI and social good, and is what are the harms? And in general, in machine learning and in the evaluation of these systems that are being developed, we see that there's often a focus on the predictions of the algorithm as the locus of evaluation. So there is a major focus on predictive performance. And in addition to this, this is in some constrained static evaluation settings. And so we have headlines such as AI is better than humans at this task, or AI beats the humans. But in reality, in many settings, we do not care about the predictions, but we care about prediction-informed decisions. And when we change the lens from the predictions to the decisions, there are some key questions that arise. In particular, there's the first question that is, are humans capable of making good use of the algorithmic recommendations to improve the quality of their decisions? And then, if so, when we're focusing on the decisions, how should this human-centered perspective inform the design and the deployment of decision support tools? And one specific task of an algorithm that is being deployed widely is what we could term risk assessment instruments. So these are algorithms that are estimating what is the likelihood that a person or a case will have poor outcomes. And based on these, inform the decisions. Oh, sorry. And this is being used across settings. And the setting we'll be focused on today is child welfare. So in the US, it is estimated that 37.4% of children experience a child protective service investigation by the age of 18. This amounts to approximately over 4 million calls. So this is what we term referrals, and involve over 7 million children. In this work, we were collaborating with Allegheny County. That is the county where Pittsburgh is located. And the pipeline of decisions in Allegheny County is the following. When a call is received, a call worker receives this call, and they have access to the information that is communicated in the call and to historical records. So there's been this effort in Allegheny County to make more and more data available to the call workers. And based on that, the human needs to make a decision, that is whether they screening the call for investigation or not. And due to the high volume of calls, that means that not every call can be investigated. And moreover, the county recognizes that there's this very big burden that is placed on the family when an investigation is open. So what this means is that you need to decide which calls are screened in. And the information that is communicated in the calls is sometimes inconclusive. This has led to this effort to create this very big data warehouse that connects different databases from across the county. So these involve interactions with the county public services, interactions with the criminal justice system. And this in turn has led to this interest in using predictive algorithms that can summarize this information, because this ends up being something like 800 variables that the call workers suddenly have access to make their decisions. And so some people have seen these as this amazing opportunity to be able to make decisions that are better quality, that reduce the risk, that a high risk case will be missed and not investigated. But it has also led many to be very concerned. In particular, in her book, Automating Inequality, Virginia Eubanks dedicates a full chapter to the Allegheny County system. And the National Coalition for Child Protection Reform published a commentary titled, Pittsburgh's Child Welfare Agency Goes Full Orwell. And so when thinking about this and when understanding what are the benefits, what are the risks, again, a central component is how are the decisions being impacted by these algorithms. And so, And so to give you an idea, so we had the system that was the call workers were using the historical records and the call, and now they have deployed since 2016 a predictive model that provides a risk score from 1 to 20, and it also provides some red flags. And the red flags are calculated based on the probability of out-of-home placement of the child. And what this means is that the call worker requires a supervisor's approval if they want to screen out the call. So the question at the center of our work is, are call workers able to dismiss algorithmic recommendations when the tool misestimates the risk? And so this connects with what Ayana was talking about earlier, that is algorithm aversion and automation bias. So in the context of algorithmic informed decisions and in general interactions with AI systems, there's two phenomena that have been observed. On one end, we have automation bias. And so this relates to what Ayana was saying of overcompliance. So these are cases in which the human just blindly follows the algorithm. This can lead to omission errors, wherein the human fails to incorporate external information that should prompt an action, and commission errors in which the human just follows a recommendation to take an action. In the healthcare system, this could be something like an invasive procedure because they blindly follow these recommendations. On the other end of the spectrum, though, you have algorithm aversion. And these are cases in which experts completely dismiss the algorithmic recommendations and choose to ignore them. And some of these can be driven by the experts seeing the algorithms make mistakes. And so once the experts see a few mistakes that they find very concerning, then they lose trust on the algorithm. The desire for control over the output can also lead to algorithm aversion. The lack of time to inspect what the algorithm is recommending and why that may be. And so these two, the research that we framed here was kind of in the context of these two phenomena, what was happening in the child welfare setting. And what we found is that call workers did alter their behavior when the algorithmic tool was deployed. So there was not a complete algorithm aversion phenomenon, but we found that they were less likely to adhere to recommendations that resulted from a misestimated score. And I'll explain about these misestimated scores in a second. So something that may be helpful for this is the timeline. So the tool was developed using data from before 2014. And then there's a pre-deployment period where we can observe how the humans were behaving, how the coworkers were behaving in the absence of the algorithm. And then there's a post-deployment period where we can observe how the coworkers adapted to the algorithm. Importantly, this post-deployment period in this study ends in December 2017, when the county discovered that there was a glitch in the tool that led to some scores being miscalculated. So what happened was some features were miscalculated in real time, leading to misestimated scores. And so what we're seeing in this heat map is in one axis, we're seeing the assessed score. So this is the score that should have been shown had there not been a bug. And in the y-axis, we're seeing what is the score that was shown. So 17% of shown scores were miscalculated by 5 or more points. The fact that you see the diagonal here very heavily colored means that still most scores are correlated. And interestingly, many cases that should have been flagged as mandatory screening were not. And so this allows us to see what happened with these when they should have been screened as mandatory screening, but they weren't, or vice versa. So the first question that we asked is, before and after, did the deployment of the tool impact call workers' decisions, or did they simply ignore the recommendations? What's their algorithm aversion? So here we're looking at the alignment of the score An important caveat here is that because the glitch was not random, but it also cannot be reproduced. And here we're looking at the score that should have been shown, so the calculated score, and the alignment with in the pre-deployment period and the post-deployment period with the screening rates. So with everything else equal, if the coworkers had entirely ignored the algorithm, we should see that these two lines look the same. Instead, what we find is that the deployment in the post-deployment screenings are better aligned with the scores. And one thing to note here is that the overall screening rate did not vary in the two periods, likely because it's driven by constraints in resources. And in particular, for those cases that received the mandatory screening, or that should have received the mandatory screening, which has a high correlation with the ones that did, we see this very sharp increase. It goes from 58% before deployment to 71% after deployment. So as a summary of this first part, what we found here is basically that the coworkers were not just completely dismissing the algorithmic recommendations, and that the algorithmic recommendations were influencing the decisions. And once we've established these, we can move to the second part of our question, that is, were coworkers able to dismiss algorithmic recommendations when the tool misestimated the risk? Or were they blindly following recommendations regardless of whether the recommendation was affected by the glitch or not? What we see here is assessed versus shown scores. And here what we see is that human decisions are better aligned with the assessed scores than the shown scores. So they are still, here in particular, when you look at the bottom of the plot, the relatively high screening rates for cases with very low shown scores suggests that the coworkers are effectively using information at their disposal to avoid many errors of omission. But here we're not seeing what happens for underestimation or overestimation, which we can look at here. So in this plot, we're seeing for the scores that were shown, which ones correspond, we're separating it into buckets of overestimation, correct, and underestimation. So the way to read this plot is, for example, for the cases with a shown score between 11 and 15, the cases for which the score was underestimation of the assessed score, these were screened in at almost 60%, whereas all the other cases were screening at around 30%. So the coworkers were screening those cases that should have received a higher score at higher rates. Again, this suggests that the coworkers make use of other pieces of information to drive these decisions. And finally, we can look at what happens for those cases that should have had a mandatory screening flag. And what we see is that even in cases where the score was underestimated by more than 12 points, the coworkers were screening in these calls. So again, this suggests that the coworkers were making use of other pieces of information to dismiss incorrect algorithmic scores. And I'm already at 15 minutes, so I'm going to just briefly say that when looking at the lessons learned, because the story is retrospective and the corruption was not systematic, not random, we cannot determine what was it that led to this positive behavior. And that's basically what we want to do in future work. That is, what is it about the characteristics of these tools that led to this positive behavior? And we do talk a little bit about the conclusions that we got to based on conversations with the county on this workshop paper that I linked here. Thank you very much.
Great. Thanks, Maria. This was really interesting talk, and I'm sure people will have a lot of questions in the Q&A session. So we'll move to the final speaker for the day. Our final speaker is Arbel Vigudni. Arbel is the Chief Operating Officer at ZAP Malaria, and they're doing some really interesting work on using AI for malaria prevention in sub-Saharan Africa. Arbel, please go ahead.
Yes, thank you. Let me know if you can see my screen.
Should be coming up.
One moment. Just a moment. Okay. I think I've got it. Just a second. How about now?
Yes, we can see it now.
Okay, great. Okay. So, hi everyone. I'm Arbel from Zap Malaria, and it's great to be here. At Zap, we develop software to enhance malaria control operations. And I'd like to talk about how we use AI to improve our ability to plan, as well as implement operations for malaria control. So I'm sure most of you have heard about malaria. It's one of the best known public health issues, and for very good reason. The yearly death toll for malaria is over 400,000 people a year. And more than half of those people are children under the age of 5, because children are much more susceptible to the infection. Now, the parasite that causes malaria is transmitted from person to person almost exclusively through the bite of a mosquito, specifically mosquitoes from the genus Anopheles. And due to this fact, the way that malaria is controlled is mostly either by preventing bites or by reducing the population of transmitting mosquitoes. Now, when you travel to a malaria endemic area, you'd usually be prescribed an antimalarial drug, instructed to use bug repellent spray on your body, and to sleep under a bed net. People who live in endemic areas cannot take drugs on a regular basis or use spray all the time, but sleeping under a bed net is one of the main ways that ministries of health try to control malaria. Other methods focus on reducing the mosquito populations. And the two main ways are either by, reducing the mosquito populations. So either by spraying the walls of houses where the mosquitoes rest after they take a blood meal. So when you spray the walls of houses, they don't make it to the next victim to transmit the parasite, or by spraying water bodies where the mosquitoes lay eggs. And the second option, the spraying of water bodies that you see here on the right of the screen, is what we focus on at Zap. And the reason is because spraying water bodies, by spraying the water bodies, we target mosquitoes at their source. All mosquitoes need the water bodies in order to lay their eggs. So whether they bite during the day or during the night, or whether they're indoor biting mosquito species or outdoor biting mosquito species, by spraying the water bodies, we can make sure that the mosquitoes can't lay eggs and can't reproduce. And historically, this is one of the main methods that were used to eliminate malaria from many places around the world, including the United States, including Israel, where Zap is based, and many other places. The problem is that even one small water body can be home to a lot of mosquitoes. So the effectiveness is greatly dependent on the proportion of water bodies that can be identified and sprayed. And another factor is the cost effectiveness of this method in different environments. And one of the key factors is the population density. So in a very densely populated area, spraying one water body protects a large number of people because there are fewer water bodies per person. But compared to that in a wetland or a very sparsely populated area, it becomes less affordable because you have a lot more water bodies per person. And so at Zap, our goal was to see whether we could digitize the process of malaria control, and if that could help achieve better results. And so we have several algorithms that we use for that purpose. And the first one is quite simple. The first one uses machine vision to identify the locations of houses and other structures. And we use that first to tell us where we can find people, where the population is the most dense. And by estimating the population density of different areas, we can estimate the cost effectiveness of spraying the water bodies at a later stage. The second step is a little bit more involved, and that one focuses on mapping out the water bodies. Now, large water bodies are quite easy to locate just by using satellite imagery. Especially we use satellites that provide infrared images, and it's really good at differentiating between land and water. But the problem is that mosquitoes actually prefer smaller water bodies, and Anopheles mosquitoes can breed in puddles as small as 1 meter across. And we cannot use satellite imagery to identify such small water bodies. So what we do is we use a combination of both topography, so we use topographical maps, as well as weather data and satellite imagery. And we use that to try and learn, using artificial intelligence, which areas are more likely to have water bodies that are suitable for mosquito breeding. Based on that, we know where to focus our efforts, or when we're considering what we already know about the population density from the previous stage, we can use simulators to analyze the information and create intervention strategies automatically for any place where we're asked to basically provide our services. And one of the reasons why our solution is so practical is actually due to simpler technology, and that's the technology that we use to implement the strategies in the field, and that's a mobile app. And Zap actually, Zap has a mobile app that actually preceded the artificial intelligence component that we have. And the original purpose of the app was to solve the issue of coverage in these control interventions. Field teams have a hard time locating and keeping track of the water bodies that need to be sprayed. And the mobile app, even before we had the AI, helps us guide workers using GPS so they know exactly how much of the area they've covered. So they know which water bodies need to be treated and when, because they do need to be sprayed at a certain frequency, at certain intervals. And it also helps workers divide the work efficiently between teams so that no one has to do more or less than they have to. And that's kind of what you see here on the map. So just to show you a little bit about what we've done with this so far. The first place where we've tested the technology was in Ghana in 2017. And we work in a city there, has around 10,000 people living there. And we work in collaboration with the local gold mine. And the local gold mine has a malaria control company or operation that they run. And we basically use it to test the technology, see that it works, see that it actually does improve the ability of the team to find water bodies, to treat them in the required frequency, and basically improve the cost effectiveness of such operations so that they could happen in the future. And we're actually just now starting an operation there. We just received the insecticide materials that we'll be using. We also have work in Ethiopia. Currently, COVID has brought that to a little bit of a halt at the minute, but we're also working in Zanzibar, and that's a project in collaboration with both the Zanzibar Ministry of Health and a couple of universities from the UK. And that's to use drones as well in the acquisition of satellite imagery so that we have a little better resolution when we're identifying these water bodies using artificial intelligence and machine vision. We're also working in Mombasa at the minute, similar projects. And if you want to see more, you can go visit our website, zapmalaria.com, and see a little bit more about what we do.
Awesome. Thanks a lot, Arbel. This was super interesting. Okay, so firstly, I'll thank the speakers on everyone's behalf for the four amazing talks, and I'll just open the sort of allow people to unmute themselves and ask questions. Yeah, okay, so if anyone has questions, they can unmute themselves and please ask.
Or maybe they can raise their hands if they want, if someone is talking. There was certainly a couple of questions for Maria. I don't know, Maria, would you like to start?
Yeah, happy to start. So, Amy is asking whether there are. So first, the fact that there's, well, the bug leads to our ability to study this is certainly very concerning. And so I totally agree. And I think that one of the elements that this study highlighted was the importance of having the humans in the loop. And while in this case, the errors that we studied were because of a bug, any algorithmic tool is going to be making mistakes. And so I think that one of the things that these results highlight is the importance of designing systems in a way that humans have this autonomy. And for the second part of the question of whether I see a way to replicate a similar design to get a bias, but in a deliberate, ethical, but still in actual deployment way. So one of the things that we're working on right now, as I emphasized at the end, was looking at trying to understand what are some of the properties of the design of this tool that led to these kind of desirable behavior of the humans being able to dismiss these incorrect recommendations. And I didn't have time to go into it, but some of the elements that have been highlighted by the county and that you can look at in the workshop paper that I pointed out, that was kind of like this addendum to the main work, is the fact that in this context, the humans have been it has been very emphasized to them that they should only be using this as the secondary piece of information. And they have had training also making the decisions without the decision support tool, right? So there's the question of what happens when there's no decision support. But to the question of whether you can study these in an ethical way where you replicate a bias, a bug, we've been looking at understanding what are characteristics that led to this, but there are very clear constraints, not just on the ethical perspective, but also on the fact that because these are very high stake decisions, the validity of the results that we're seeing from the actual deployment is something that even if you're doing a study with the co-workers in the tasks that they're solving, it is not very clear that what they would say they would do and what they would believe they would do in a hypothetical scenario is what they would actually do when they're receiving a call when a child is at risk. And so the high stakes nature of the decisions in this context is one of the elements that I want to highlight, make it particularly hard to derive conclusions that have validity in terms of what will actually happen when you're studying it in constrained experimental setups. And I think that was there any other question that I missed?
I had a much more general question, I guess, which I did direct to you. I can ask that, and maybe I can also kind of frame that as a question for Milind in addition. So the idea of defining social good, right? Like we generally kind of think that if we move towards a direction of social good, we're thinking about one set of goals that we might want. Now, especially in the case of the examples that Milind, you brought up, I imagine that working in the area of social good might potentially compromise the interests of some of the stakeholders that are involved. So for instance, those of the frontline health workers. And I'm wondering if you came across any such examples in the work that you were doing, say with Arman or in your other case studies. Did you find that there was kind of this tension around what social good and whose social good you were trying to get at?
So I mean, that's a really, really interesting question. And one of the case studies which we went after illustrates what you're saying, Neha, very well. So this is trying to protect forests from illegal loggers, the people who come into the forest and try to prevent illegal logging. And so our job is to kind of prevent this illegal logging. So we, as we did with the illegal, with the poaching, our job was to provide patrolling strategies for rangers to prevent forests being cut. And so we presented our study to the World Bank at some point, and the response was that essentially our objective function, which was trying to say we want to actually reduce completely, the amount of wood being cut, is not what the World Bank seems to want. At least that was my interpretation. The idea is that the surrounding communities, they are dependent on the forest. The people who, so essentially the idea is that we kind of want to protect the forest so that it's not completely eliminated, but we don't also want to with AI enhance the capabilities to a point where people really find it hard to get into the forest and take away the products that they need for their livelihood. So there's a little bit of sort of give and take. So let's try to be a little loose in how effective we want our AI to be, because we really want. So I agree with you that these are things which so that's why in our work, at least, one of the key points is to really try and, as much as possible, immerse ourselves in the domain, to try to visit the sites, try and talk to the nonprofits, try and talk to whatever stakeholders we can get hold of, and kind of try to balance as much as possible the needs. But on the other hand, it is also the case that there's limits to and I can go to many examples. I know there are other questions that are coming in the chat window, so I don't want to monopolize the time here. But I guess the other thing is that we also don't want to fall into a trap of being immobilized by having to continuously consider all sides of all issues, because at some point we do want to accomplish things by actually seeing things work in the field. And so the idea is that we implement things after due consideration, and if it turns out that newer issues come up, certainly we want to kind of take them and modify whatever it is that we're doing, modify the tools that are being built.
Thank you, Milind. There's a few questions in the chat for Maria, and then two for Ayana. So I want to maybe start with one for Ayana. That's Rajesh's question, if you had a chance to read it. Rajesh, do you want to just speak? I can read out what you've written, but you can just share your thoughts.
Yeah, sure. No, it was a great talk, everybody, and I just had I don't have an opinion on it. I just and hope that should we leave machines as machines and then de-racialize them, or should we, Akhil also seems to join on to this question of, and he says it nicely, better than mine, should we use robots and AI models more explainable? Like the Sendhil Mullanan wrote the piece as well, where maybe the machines can actually debias better than humans are. And so the question is, just kind of just pushing a little bit back on the question of de-racializing robots, and I'm sure you have more thoughts on that.
Yeah, so if you'd asked me 5 years ago, I would say, robots should be robots and people should be people. But the fact is we don't really have a choice. One of the things is that the acceleration of AI is it's going without us holding on. It's like the train has left. And so I think about, given that the weapons are already out, how do you then provide some type of scaffold to ensure that those weapons don't become nuclear weapons is really what I think about. And so one of the things that we can do is ensure that we, one, don't put these human characteristics that evoke triggers, because we know when we gender and we add race, it evokes triggers, right? And that's a fact. So we should kind of take that off the table. And then given that AI is already out there, how do we use it, and how do we think about the fact that it has modeled us? It has all this data, but it can do better things. I'm of the proponent that I honestly think that Alexa should tell us off, right? I honestly think that if we start yelling at Alexa, Alexa should say, I'm not doing that. I'm off until tomorrow, right? And we won't do that. But I think that would help us kind of stop and think, oh, right, I'm acting inappropriate. I'm acting like a human. I need to do better. I wouldn't have said this 5 years ago, trust me. But now I think we're at an instance where we have to make more drastic efforts to ensure that we don't screw up this world.
Thank you, Rihanna. Did you want to follow up, Rajesh?
Yeah, I guess I'm on the same view though. You are, so I guess maybe I don't understand what you're saying then. Like I had thought that you are saying you want to leave the machines as machines, right? So because if you want to take off the features which are racialized that you pointed out, you're basically saying, hey, let's get to a state where we try and present these objects as machines as neutral. And I'm just wondering whether that's possible. So I was thinking like, or hoping that, maybe it's like we need the robots to kind of, bail us out now and then stick it to us and say, well, hey, we're also damn biased about, and so, but I was just more interested in seeing whether there's any like careful, is there a way to kind of think through that, like, in a research study or something, to, I mean, like you were doing, right, to kind of see like how does that change, if you explicitly racialize it, and then fix for the bias, and then tell them, hey, like the Alexa pointed out, you brilliantly pointed out, like, is there a similar thing saying, hey, catch your bias, and is there a hope for fixing our condition?
Yes, so one of the things about, if I think, and I'll use race because that's actually harder to talk about for a lot of people. So the problem is if you add in race, you are also, remember the developers, where most of us are trained in the US, right? So we have a US centric point of view. And so our biases are really US based. But if I go to Japan, it's different. If I go to China, it's different. When I go to India. And so when we start thinking about race, we're now still saying that we are going to take a region of the world and we're going to put in this aspect. I think AI should have human attributes in terms of interactions, because there's things like saying thank you. It doesn't matter what your race or gender is. It's like people understand that if thank you is a form of, admiration, love, or whatever you want to call it. But if you then have it as your mom that says thank you, because female, or your dad that says thank you, those evoke different behaviors and different triggers. And so I'm saying, let's take those triggers out that we know because of the way we grew up. We have triggers, and those triggers make us think about things differently. Take those away, but the human interactions that are there, irrespective of race, gender, or age, that we pretty much understand, those are the ones we should keep and use those to then help us correct for our biases. I would say, yes, let's make all the robots surgeons females and make all the robot assistants males, right? That would be like a shock to the entire system. But I'm actually not of that proponent, because that means that it's my bias that's enforcing that, which I, again, disagree with.
So we have a couple of questions for Arbel. So one question, Arbel, is can you talk a bit about the training that you had to provide to the people who are using the mobile app in the field for the data collection? Because I believe that's like a critical component of the entire system. So how did you train those users?
So most of them, I actually traveled to those locations to train personally. And so I trained a few of the guys there, and they just paid it forward and trained the rest of the team themselves. So I did the initial training, and that's how we usually do it. We actually go ourselves to help them set up, make sure everything works, that they know how to use it, that they know how to, that it can be sustained by the people working there. And then we just, run it remotely from here, from our offices.
Awesome. And I think Amy also has a question about, I can read the question, like targeting more densely populated areas in some ways sounds like it would be replicating the inequalities of more or less remote areas. So like if you target more populated areas, then perhaps the less populated ones do not get enough attention in a way. So maybe if you can comment on that. Or Amy can maybe ask the question if I didn't get it right.
Yeah, sorry, I was making some food earlier, but I think my question was basically like targeting more or less populated areas, at least in some contexts, might be replicating certain inequalities of, let's say, like urban or rural, or even within a rural area, like certain denser populated versus less dense populated areas getting serviced. Is that something that as the ML developer, like there are ways for us to address that, or basically whose responsibility is it to make sure that this is accounted for?
Right. So we actually, it's a really good question, and it's occurred to us as well in our work. And so the way we think about it is, you know, the governments that we work with, or the organizations that we work with, are already have a certain amount of resources that they use to roll out these interventions. And what we try and do is we help extend these resources as much as possible so that a greater area is served. Because usually these interventions, they're not happening everywhere. They're happening only in particular places that have been able to get funding for certain activities. So whereas, I mean, you could see it in a way as certain areas getting interventions that other areas won't be getting. A larger area is being served as a result of the optimization that is happening compared to what would have happened without it. And another thing is that in the future, what we hope to do is of course, right now we're working with the water body spraying, which is one of the methods that was used to eliminate malaria, because we believe that's the best way to do it in the context of actually eliminating it. But places where you're not doing this form of intervention, you can do other forms of interventions that would be more cost effective in those environments. So for example, you could decide, okay, I'm doing this intervention here, and everywhere else I'll focus on something that would work better there. So I mean, that's how we see it, and that's how we hope it'll happen in the future.
Cool, thanks.
So, Tim, I think you had a question for Maria. Would you like to ask your question?
Hi, Maria. Can you guys hear me?
Yes.
Awesome. Let me scroll up. I was wondering, with the risk scores in your study, if I understood correctly, you were kind of displayed this risk score between 1 and 20. I'm wondering, what other forms could feedback be that is truly useful to humans at that exact stage? And how we might be thinking about giving such feedback, or kind of how to go that direction, to go beyond kind of AI that just kind of spits out some risk scores that sometimes work, sometimes don't work so well, and how we could also use AI to support the kind of human processes that are happening there in some deeper way beyond a single number. Thanks for the great.
That is a fantastic question. And so one thing that I'll clarify first is that in this case, our team was not involved in the design of the tool or anything like that. We were just involved on the auditing of the tool. And so this was a tool that was deployed in 2016. And our work there was in doing the auditing and understanding what was going on But in general, as you point out, there's definitely, so there's two things that come to my mind related to your question that I'll comment on here. One is when you have a risk score, one of the elements that we often think about as additional to these is, oh, should we provide explanations? And one of the things that we speculate about in terms of what may have led to this positive behavior of the co-workers is whether the absence of explanations may have actually helped, and whether having explanations could have led the co-workers to trust the system even more and have this kind of like blind trust. And so there's some results, for example, from Hima Lakaraju, and also work done at Microsoft that shows how when you have explanations, sometimes that leads humans to have even more overcompliance. And so that is one thing that is interesting when we're thinking about what we mean by trust in the system, right? And wanting the human to use the information, but still be critical. But of course, what you asked was much more general, and you were not mentioning explanations in particular. And I definitely think that there's a lot of other tasks that the ML systems may do that augment the quality of decisions. And in particular, one thing that I'm very interested on and starting to work on now is how ML can actually help augment teamwork. So instead of trying to give, as you say, these prediction scores that is just like, oh, you should do this, or there's like a 17, which there's a whole other conversation of what does a score from 1 to 20 mean to us humans, and how do we even interpret these calibrations. But also I completely agree with you, and I think it's a great point that there's many ways in which we can reimagine the task of the machine learning system. A recent work on suggesting when a second opinion may be useful, I think is a great example of this. So in short, yes, I think that there's many ways in which we can provide other informations to the humans that can improve the quality of their decisions even more than just framing it as predictive scores.
Thank you, Maria. Okay, so there is a question. Okay, there's conversation going on, but let me just go back to Milind. Maybe you can share what we just talked about. So just in engaging with, because you're working in all these ecologies where there are so many different stakeholders, right? So how do you, I guess, what has been your experience in terms of wearing a Google hat versus wearing an academia hat, and how do you are you able to kind of use that to your advantage, really?
Yes, I think there is a difference, and I think I wanted to highlight a workshop we are organizing because it might be of interest to the attendees here. So I guess the idea at Google Research India has been to do matchmaking between academics and nonprofits. So last year we invited professors and we invited nonprofits to come. The nonprofits pitched problems, the professors pitched their expertise, and then we did a matchmaking, and then we came out with project proposals, and then we funded proposals. So the nonprofits got something like $20,000 each. The faculty members got some appropriate for India at that time, $10,000 to $15,000, and that led to 6 projects being launched. And once they sort of reached a particular stage of maturity, there was more funding and all kinds of great stuff. So now we are trying to, now that we sort of got confidence in this model, we are expanding the model. So I wanted to say there is a workshop called Out. So nonprofits will come from India, Africa, and Southeast Asia, and faculty members from around the world can apply. And the basic idea is for us to do then matchmaking and essentially follow the same model. And we'll fund the nonprofit, we'll also fund the faculty members for a pilot. And once the pilot is successful, then we will, make everything available. Basically we'll potentially fund, can't guarantee, but, beyond the pilot, but that's what happened earlier. So now we'll be from 6, there'll be a significant jump. I don't know exactly how much, but there'll be, more than 2 or 3 fold. It'll be like a lot many more projects that we want to launch. So this kind of work, I mean, first, I hope this is of interest, and I hope people will apply if they're interested in working with nonprofits in India, Africa, and Southeast Asia. But this kind of, thinking and being able to sort of marshal forces to get people funded and launch this kind of work, I feel was very interesting that I could do from Google Research India. And so that's one difference I have found. Receptivity of the message, I guess each sort of institution brings its own weight to bear in terms of positives and negatives. I think I personally feel being in India as Google Research India allows me like more access to nonprofits in India, because they sort of think of me as, okay, you're not kind of over there telling us what to do. So it's a little bit better that way. And of course, for nonprofits in Boston area and so forth, it would be hard to approach them from a Google Research India perspective. So, and I'm sure there is I can go into other pros and cons, but I'll send out a link on the in the chat window to the workshop. If people are interested, please apply.
Sounds great. Thank you. So Rajesh, did you have a follow-up question for Yana? Because I know you shared a paper.
Yeah, done.
Sorry, did you say no? I didn't catch.
No, I don't.
Okay. Any other questions from anyone?
I have one more question for Milind. So I was wondering, like, I think you mentioned that lack of data is a feature in a lot of the AI for social good projects. I'm also wondering, like, even if we have the data, it is incredibly noisy in the real world. And then there's always this question whether we invest more on like data processing algorithms, or do we go back and actually do the data collection from scratch in the hope of training better models? So what's your take on like these two aspects?
I think we're sort of fundamentally limited on the data side. There's just like when we mentioned spreading information about HIV, there is no social network data available, and we cannot go and harass all of the kids to say, give us your social network. I mean, maybe we can ask questions of a small fraction, which is what we did, sampling the social network. But it is really not possible to say, tell our social work colleagues to sit in the homeless shelter and just sort of talk to everybody. So there are, in some sense, if we want to do the AI work, we cannot go out there and say, we are now going to, put a lot of burden on the nonprofit or the community that we are serving in order to make our lives easier. It just seems like we have to work harder. And I think it's a really great point about, what is the exact trade-off? It could be that for a little bit more of data, we could significantly simplify the algorithm or something like that. And those trade-offs have to be studied. But we have fundamental limits here. The wildlife rangers, they're limited. I mean, they can only patrol a small fraction of the national parks. And we can't say, well, why isn't this like, police, why aren't you sort of going around the whole park? They just can't. I mean, there's just very limited numbers. So I think we have some very fundamental limits that we have to work with.
Great, yeah, thank you. That's a great point. Any other questions?
Yeah, if not, I guess we can. Can I just, since there aren't any questions and we have a few minutes, can I just ask a very broad, very high level question? And anyone who feels comfortable asking is in this framing of AI and social good, is there a particular way that you think about social good? Like what checks off the box of social good versus not?
Yeah, I'm sorry I missed the question earlier when you asked it. I only afterwards when when you pointed out, I saw that it was in the chat. I think that one thing that is I find particularly challenging. I've actually never defined myself, my work as AI for social good, precisely because of what you highlight. That is, how exactly do we define what is AI for social good? And as I think Genevieve pointed out, it's like, well, the other stuff is like AI for bad. Like what? Like I would say that loosely, like if I had to loosely define it, it would probably be situations in which the objective is not linked to a firm's utility maximizing context. But I think that one of the things that I really like of this session is the fact that the title was AI and social good and not AI for social good, that I think that really emphasizes, again, what Genevieve pointed out earlier, of we need to think about the societal impact of any AI technology. And as you suggested in your question, we need to do that from many different perspectives, because what may be what may be very positive for someone may be very harmful for others. And there's both the different perspectives, but also core elements like the intersectionality component of, if we're designing for a community, then like, how is it that different individuals in that community are being impacted by the technology beyond this like overall perspective that we're looking at through a lot of the evaluation metrics that we often consider?
It's I guess I'll say it's a great question, something that we really need to think about. In I guess so far, some of the thoughts we've had, AI for social good, first of all, there has to be something beyond a paper in AI for, when we say it's AI for social good, we show me the social good or show me the social impact, and don't stop at a paper. Generally speaking, the work has, in our view, would need to be about marginalized communities, endangered communities, and generally places where there hasn't been AI investments. In some ways, I guess all of us are struggling with the fact that, you know, the benefits of AI go to a small slice of the world's population. And the question is, how can we make it more available to, you know, a larger fraction of the world? At the same time, very well recognizing that there are conflicting conflicts in the stakeholders' sort of objectives sometimes, and we don't want to sort of from very far away, thousands of miles away, sort of, okay, here's a parachute of an AI solution, and you know, we haven't sort of thought through all these conflicting objectives, and so those are definitely important things to consider.
I'll add in my 2 cents. So I think simply, it's, if you think about our fundamental human rights, the UN has a list of them. And so when I think about social good, I think about AI that's used to either increase access, equity, or the quality of those human rights that we kind of have as humans, or we're supposed to have. And so AI that does that in any form or fashion, matrix, is under that umbrella.
Thank you, Ayana. Arbel?
Well, honestly, we had to think about it when we joined the X Prize competition that we're part of. There was like a huge ethical questionnaire that we had to make sure that we addressed. But to be honest, for us, it was first, we had this goal to use technology for a certain purpose, and then we realized, oh, this is considered social good, so our AI must be AI for social good. We didn't really have the, you know, a really, you know, maybe thorough discussion of what social good is. So I'm not sure, but that's how we came to be, you know, to consider ourselves AI for social good, by first having AI for a certain purpose and then falling into the category.
Yeah, thank you. I mean, I think what you're also saying maybe is that some of these areas that we're so familiar with as being social good, like the association goes back, I guess, many years, decades. And with malaria, I suppose that is directly related to some of the, as Ayana mentioned, also like the UN goals around health and global health in general is strongly associated with social and global good. So that makes sense. Thank you, everybody. We're 3 minutes over. Akhil, did you want to add anything?
So firstly, I would apologize because I started the recording a bit late, so we
Yeah,
missed
so sorry.
talk. So I'm sorry for that. But rest of the talk would be available on YouTube. So in case you have some students or collaborators who want to listen to the talks, please check our website.
And maybe I can follow up with you, Ayana, and just get slides for your talk if you think that's okay, so we can at least share those. And we'll have the Q&A in the recording as well. So yeah. Wonderful. And so in December, we're going to be doing our session on community networks that Curtis is going to be leading. Thank you all so much for attending. It was wonderful to see you. Take care.
Thank you.
Bye.
Thank you. Thank you for organizing.
Thank you very much. Bye.
Thank you, everyone.